So today we're going to talk about the cross product. So just a simple definition for the cross product. If we have two vectors, we can take the cross product between them. So in this case, we'd say A cross B. So if A is A sub x, A sub y, and A sub z, if those are the components of it, and B is similar, B sub x, B sub y, and B sub z, then A cross B equals C. Then C, the result of A cross B would be what you see there. So A sub y B sub z minus A sub z B sub y minus A sub x B sub z minus A sub z B sub x plus A sub x B sub y minus A sub y B sub x. So that's a bit of a long formula to remember, but there are some ways that you can remember it, and we'll go over one a little bit later to do with determinants. But in the meantime, the cross product also represents the magnitudes of both the vectors multiplied together times the sine of the angle between them times the unit vector of the cross product. So sometimes that formula comes in useful if you want to find, for example, the unit vector of the cross product. Just some laws for the cross product. So commutative law is not valid. So this means that A cross B cross C is not the same as A cross C cross B or any other combinations. As well, this kind of goes along with it. A cross B is not equal to B cross A. It's actually equal to negative B cross A. But scalar multiplication is valid. So if you have a scalar, for example, A times the vectors A cross B, you can put that scalar in anywhere and it will remain the same. So here's where we get to matrices. So a matrix is basically, essentially it's a system of equations, but we can see it kind of as a way to organize our work in this case. So we can see in the matrix there, we have I, j, and k. So those are our coordinate directions. So those are the components. And then the second row is vector A, the components of vector A, and the third row is the components of vector B. Just some notes, if two rows and two columns are equal, then the determinant equals 0. And we'll see that in a bit because that's sort of the way the math works out. And you can look back at that formula, and that's the way the math will work out with that one. If any row or column is multiplied by a value, then the determinant is also multiplied by that same value. So kind of similar to that scalar rule. And the determinant of a 3x3 matrix, or one that's composed of two vectors, is equal to its cross product. So we'll go into the determinant of a 3x3 matrix. So again, this is equal to the cross product. It's just a different way of finding the cross product. So to find the determinant, you can either use the same formula as above, which we already discussed, or we can find the determinants of each Cartesian vector component. So just some rules for this, and these are very basic rules. Do not use any of the values in the same column as the component. Multiply the other components, so top left by bottom right minus bottom left by top right. And then overall it'll be I component minus j component plus k component. So for that, that's sort of more of a procedure. So if you see below for the 2x2 determinant, that's how you'd find a 2x2 determinant, and basically just find a bunch of 2x2 determinants for the 3x3 matrix. So I'll show you what that looks like. I know that's probably kind of confusing, but yeah, I'll show you what that looks like in this example here. So we want to calculate A cross B using the determinant of the matrix. So first we have to form the matrix with vectors A and B, and then we have to find the determinant of it, and that will give us the cross product, where A is 2, 4, 5, and B is 1, 4, 6. And then we want to calculate B cross A. And then just as an extra example, we can calculate A cross B, different A cross B this time though, just simply using the formula as discussed in one of the first slides. But for now, we'll use the matrix approach. So we have A is equal to 2, 4, 5, and B is equal to 1, 4, 6. So then we can put this into the matrix. So I, J, and K, or the sort of the X, Y, and Z cardinal directions there. And then we'll put in our, so I'll just put in, oops, sorry. So there's the components, and this is A, and this will be B. So A is 2, 4, 5, and then you just line them up like that nicely. And B is 1, 4, 6. So that's what the matrix is going to look like. Now we want to find the determinant of this matrix. So we're going to start with I. And what we have to do for I is we'll look at so we'll disregard the I column, but what we're going to do is we'll look at the determinant of this here. So that would be basically that. So 4 times 6. So this 4 up here times this 6 minus 4 times 5. Okay? So four times 6 minus 4 times 5. That'll be I. And then we want to go minus. And then we'll do J. So we'll do sort of the same thing. Except we'll take out the J column. And we'll do 2 by 6. And then 6, 2 by 6 minus 1 by 5. Okay. So 2 times 6 minus 1 times 5, J. And just remember this minus here. This is the only one that has the minus. The J term always has a minus. That kind of goes into linear algebra a bit, but sort of just take it as fact for now, I suppose, because you won't really be needing to solve any in this course. You shouldn't need to solve any bigger matrices in this course. Anyway, and then we'll say plus, and then we'll have our K term, which, again, we'll disregard the K column, and we'll just look at these. And then we'll go 2 by 4 minus 1 by 4. Okay? So 2 times 4 minus 1 times 4. Oh, sorry. K. So then we can simplify this. So 4 by 6 is 24 minus 20I minus 12 minus 5J plus 8 minus 4K. So then this will be equal to 4I minus, so 12 minus 5 is 7, so minus 7J plus 4K. So then this will just be a vector C, which is equal to 4, -7, 4. And that's the cross product between those two, between A and B. So let's put up here A cross B. Okay, now we want to find B cross A. And we can do that using either the matrix or the formula, but the easiest would be to use the properties, which is this second one here, A cross B is equal to -B cross A. So that follows through that B cross A is equal to -A cross B is equal to -C here. Sorry, I should have those vector symbols, which is equal to -4, -7, 4, and then just putting those in. And it's as simple as that. So I hope you enjoyed. I hope this was helpful. Thank you to Google Keep and Loom, and as well to my professors. And I hope to see you again next time.